All right, so today I just wanted to go over a little bit more about the fundamental theorem of calc and how it applies to make sure we really understand exactly what we learned in the other sections. All right, so the first thing right here, it says that I want to take the antiderivative of this function from 1 to x. So what that would be is that this would be t squared plus 3t, and I need to evaluate that from 1 to x. And then I see it froze up again. Okay, so then I put x in there, so I get x squared plus 3x minus plugging 1 into there. So that'd be 1 plus 3 is 4. So then this equals x squared plus 3x minus 4. On this one now, it's telling me to take the derivative of this answer. So here's the function. Now I just need to take its derivative. So I need to take the derivative of the x squared plus 3x minus 4. So when I do that, the derivative of x squared is 2x. The derivative of the 3x is 3. Okay, we'll try the same thing down here. Take the antiderivative of this, so that would be t cubed minus 3t squared plus 5t evaluated. So plug in x, I get x cubed minus 3x squared. Plug in 3. Oh, what did I do? I hate that stupid power button. That should cancel. It should be 15. I don't know why I'm getting a calculator. It is 15. So then I plug that in, it would be minus. Plugging in 3 is 15. So right here is the antiderivative of that. So now this is to take its derivative. So if I take this derivative, I get 3x squared minus 6x plus 5. And so what we should be noticing is that when I took the derivative of the antiderivative, I got my function back, just with an x instead of a t. I took the derivative of an antiderivative, I got my function back with an x instead of a t. So that's the what we should have noticed. So here we're going to do a few where it's not just x at the top, and we're going to try to conclude something about that. So this one right here, take the antiderivative of that would be what, sine of t from 6 to 2x squared. So put in the top minus sine of 6. So that's the antiderivative. Now I'm going to take the derivative of this function. So when I take the derivative of this, I'm going to get a chain rule for this sine function. So the derivative of this would be cosine of 2x squared times the derivative of the inside, so times of 4x. And then the derivative of 0 is just 0. So really I get 4x cosine of 2x squared. So I didn't just get the function back. All right, let's see what happens here. So this is e to the t. So the antiderivative of e to the t is e to the t evaluated from here. So that would be e to the cosine of x minus e to the 3. So now take the derivative of this function. So the derivative of e to the x is e to whatever that is times the derivative of the exponent. So that's going to be the derivative of that is negative sine x. Derivative of a number 0. So this becomes negative sine x e to the cosine of x. So hopefully you realize that when we have something besides just an x on the top, you're seeing something different. So what this difference is that I'm seeing is that I have taken the derivative of it. So I plugged in the 2x squared for x, but now I did times the derivative of it. I plugged in the cosine of x for t and then took the derivative of it. So that's the extra part. So don't forget you have to take the derivative of it. So that was a really big thing. Right here it tells you the rule. So it's f of u times the derivative of your u. So I have a couple down here I want us to try without like actually having to plug it in or anything. So so I want you to find the derivative of this antiderivative. So the derivative of the antiderivative, so I plugged that in, so 2 there plus 5 times, so I plugged that in, and then it's times the derivative of that, times 2x. Okay, so really if you want to make this look nicer, it'd be what? 4x cubed plus 10x. All right, for B here, what this rule was, hopefully you realize in your notes, is that we're going to be subtracting them, because technically you're going 2 to the x is 0 plus 0 to x cubed, so that makes this 0. Oh, I feel like I know that number, but sorry, someone's calling me on my phone. Here, so then you have to flip this one to make the rule happen, so that's why it's always subtraction. So put in your x cubed, so I get 4x cubed squared plus 2 times x cubed times its derivative, so times 3x squared, minus plugging in 2x times its derivative. So 4 times 2x squared plus 2 times 2x. And this whole thing is times a 2. So I'm going to put it up here. So what that looks like is 4x to the 6 plus 2x cubed times a 3x squared. So you got to multiply that in if you want to. Minus, let's see, there's a 2 back here. So let's just make that. And see, that would be 4 times 4 is 16, so 32 x squared. And that's 2 times 2 times 2, so 2, 4, 8. Oh, that'd be minus 2, minus 8x. Right? This right here, I changed it to put the x on bottom. So all you got to do is flip it and put it in. So it's going to become a negative now. And it is a 7x being cubed times 7. So that's 7 times 7 cubed. This would equal negative 2401x cubed. Okay. Same thing here. Plug it in and subtract them. So I have 2x cubed plus 7 times 6x squared minus plugging this in. X squared plus 7 times a 2x. I see the screen is frozen again. Let's see if there's anything else that I wanted to make sure that we got under here. All right, so just to make sure, I think we've talked about this too, but just as a few extra problems. So to take the antiderivative of this, and then we're going to do top minus the bottom. So antiderivative of 4x would be 2x squared. So I added and divided by it. And now plug in the top minus plug in the bottom. And make sure you, even though that's 0, check it, because a lot of times when you plug in 0 on the AP exam, it's actually going to give you an answer. So this is 9, so this answer is 18. So this one right here would be 2x evaluated at 2 to negative 1. So that gives me 4 minus a negative 2. So our answer is 6. Okay. So you're just taking antiderivatives, top minus bottom. That's the fundamental theorem, top minus bottom.